Hi everyone, welcome to our webinar today. The topic for today's webinar is cutting demand charges with battery storage. This webinar is being presented by Clean Energy Group's Resilient Power Project, and we have with us a guest speaker from NG Storage. Before I pass it over to our speakers for today, I'd like to go over a few quick housekeeping notes. So if you'd like to view the webinar presentation full screen and minimize the webinar console, you can do that by clicking on the orange arrow that you see circled here. To join the audio portion of the webinar, you've got a couple of options. You can call in using your telephone, or you can connect using your computer mic and speakers. A very important note, we ask that you please submit your questions and your comments by typing them into the question box on the webinar console and hitting send. We will be having a Q&A following the presentation. We're hoping to save 10 to 15 minutes for that. And we do have a lot of people on the line today, so we're expecting a lot of questions. And to make sure that we get to your question, type it in early when you think of it. Don't wait until the very end to type your question in. We'll get to as many as we can. So again, type your question in when you think of it to make sure that we've got the best chance to answer it. And a final note, this webinar is being recorded. We will send you an email probably this afternoon with a link to the webinar recording and a PDF of the slides. And we'll also be posting all of the webinar materials on our website at resilient-power.org or also at cleanegroup.org. And on that website, you can also find all of our previous webinar slides and recordings. So with that, I would like to pass it over to our host for today's webinar, Seth Mullendor. Seth is a Vice President and Project Director here at Clean Energy Group, and he is going to give you some background info to get us started.
Great. Thank you, Sam, and thanks to everyone for joining us today. I'm just going to give you a little bit of background about the Resilient Power Project and who we are before kicking things over into our presentations for today. So the Resilient Power Project, as Sam says, project of the Clean Energy Group, is supported by a number of different foundations. We have their names here. Clean Energy Group also has a sister organization called the Clean Energy States Alliance. That is an organization mainly of state energy offices and other entities that manage state clean energy funds. The Resilient Power Project has been active for a few years now. Really came at first in the wake of Superstorm Sandy. The goal of the project is to increase access for disadvantaged communities, for vulnerable communities, low income, senior, disabled communities that are at risk during power outages. During Superstorm Sandy and the recent hurricanes that hit the Southeast and Puerto Rico, we saw that the widespread outages really impacted disadvantaged communities the most, and that the diesel generators pretty much on a wide scale were prone to failure. So we were looking for a better, more resilient and reliable alternative to traditional generators to provide backup power in emergency situations for those communities. The technology combination that we tend to use in the projects that we support is solar combined with energy storage. We come at this from both the top-down approach, trying to get the right policies, regulations, and incentives in place to increase access to solar and storage projects. And we also, from a bottom-up approach, we work with communities, cities, and individual building owners to try to get projects done in affordable housing and critical public community facilities such as emergency shelters, medical clinics, first responders, things like that. In that vein, we do have a couple of small grant programs where we provide some support to help offset some of the pre-development costs in projects and to help community groups, nonprofit community organizations build up their capacity around understanding solar and storage technologies and how those can be applied to the communities that they work in. Down below, you see a number of reports that we put out. We do a lot of analysis around this resiliency and the economic case for energy storage in particular, which is less understood than solar. So on our project work, we have, since the beginning of the project, supported more than 100 projects across the country. There are a few of them identified here. We also have a leadership grant a program that helps build capacity among organizations I mentioned earlier. So this is just an example of where some of our projects are across the United States. So today we're going to be talking specifically about demand charges. And if you don't know what demand charges are, we will have some information about that so you can understand them better. We are honored to have with us Steve Kelly, who is a Senior Vice President with NG Storage. And Steve has over 25 years of experience in the renewable energy and high-tech sectors. Before passing things over to him, I'm just going to give a quick, brief background to get things keyed up and provide a little kind of more information about demand charges and why we're here today talking about them. So why should people care about demand charges? Well, if you look at this bill, this is an actual representative bill. This is summing up the annual bill for an affordable housing property that is in San Diego. And you'll see here the breakdown of charges. There's energy charges, which most folks are familiar with, but it's the per kilowatt hour. And there's fixed charges, which you can't do a whole lot about. They're just charges that you get charged by the utility each month. And then there are demand charges, and these are per kilowatt. The important takeaway from this real world example is the percentages. You'll see demand charges here account for 46% of the bill. That's not uncommon, and you'll see across the country that in a lot of places, demand charges are a significant portion of the bill, for anywhere from a quarter of the bill up to 75%, depending on where you are. So what are they exactly? As I said, demand charges are different than energy or consumption charges. They really are based on the rate that you use electricity. So whereas your energy consumption charge tracks the amount of kilowatt hours you use over a month, the demand charge tracks the highest rate of use over that month. So the more devices, the more power intensive things you're using at the same time, the higher your demand is going to be. And if you have a spike in that demand, that's going to increase your demand charges. That highest level is called your peak demand for the month, and it's measured in kilowatts instead of kilowatt hours. Usually these are applied just to commercial customers, although there are places where residential customers are subject to demand charges as well. Not that prevalent today, but utilities are increasingly exploring that for residential customers. This is just a graphic quickly to kind of visualize the difference between consumption and demand. A lot of words here, you don't have to read all of that. The basic takeaway is you've got two buildings here, building A and building B, building A on the left, building B in the middle. Building A, you can see the lights are on all day long in every unit there. They're using a lot of consumption throughout the day, and they have a high level of demand. Building B, not as many lights are in the morning. They're all on midday, and then in the evening there's less on. They use less energy throughout the day, but their peak level of demand, that dotted line at the top, is the same for the two buildings. So their demand charges would be the same. The third graphic there just shows how you could store energy in the morning and then discharge it from your battery in the middle of the day to level out that peak demand and lower that demand threshold. Steve's going to get into that a lot more later on, so I'm not going to dwell on that here. Just a bit more, who pays demand charges? It's most commercial customers, medium to large, and in some places even smaller customers. Some places almost all customers are subject to demand charges. And we're talking about businesses, but we're also talking about community facilities, public facilities, things like multifamily housing, churches, emergency shelters. It's not just limited to traditional businesses. We did a report with the National Renewable Energy Laboratory that did a survey of over 10,000 utility rates across the country, and they found that nearly 5 million commercial customers could be subscribed to a rate tariff that had demand charges high enough where energy storage could start to make economic sense. Typically, we found kind of around $15 per kilowatt. Doesn't mean that it will make sense, but it's just the beginning stage of where it might make sense to look at it that we've found. And that represents about a quarter of commercial properties in the U.S. This is just a map here showing where demand charges are higher. In the darker the shading, the higher the demand charges are for certain utility territories, certain tariffs within those territories. On the right side there, you'll see the breakdown of the highest demand charges across different states. There's some that are not a surprise, like New York and California, but third in there, you'll see Colorado, and there are some what we thought were surprising states that showed up, such as Nebraska, Georgia, and North Carolina. So these aren't just limited to places where you think of high energy charges. They're really spread widely across the United States. So with that, I'm going to turn things over to Steve to give you a much more in-depth look at demand charges and how battery storage can help manage those demand charges. So Steve, let's turn it over to you.
Hey, Seth, thank you very much, and appreciate the opportunity to have this discussion. I think it's very timely, and we've seen just an explosion of energy storage throughout the country. I think, even just this webinar that I think we've got almost now close to 300 people attending really does show the level of interest and how energy storage, I think, can benefit a broad set of different clients across the U.S. And across North America. So with that, I'll kind of move it forward a little bit here and talk a little bit more about energy storage, why it's valuable, what people are using it for. But I think first, you have to understand some of the things that are happening in the grid today. There is a broad set of challenges that the grid is trying to deal with. You have the impact of new solar and wind coming on. You've got transmission constraints. You've got supply that's changing with nuclear power being decommissioned, coal plants being decommissioned, solar increasing. And this is creating a lot of havoc for grid operators. And they're trying to figure out how, and ISOs, they're trying to figure out how to manage these costs and really develop a stable, resilient grid. There's a lot of ways to solve this problem. Some people are saying, well, just build more plants. Some people are saying just build more infrastructure and transmission. But I think the trend that we're seeing is really deploying more distributed renewable energy that you can store and utilize closer to where it's being consumed. And you've seen those trends happen, across the U.S. And as solar today is getting below 3 cents a kilowatt hour, which is competing very effectively with coal, natural gas peakers, we think that trend is going to continue. So how can you use this really to help, I think, your own facility here? But before I get into that, I'll give you a little bit of background about us just to help out. NG is one of the largest energy storage companies in the U.S. and globally. NG Storage, which is the division of NG, is headquartered here in Silicon Valley. We've done hundreds of projects across the U.S., and we've been doing this for about 7 years. I think one of the nice things, too, is Navigant has ranked us the #1 provider last year and the highest the year before. So to give you an idea of some of the customers, we've got a broad set of commercial clients as well as utility and network providers, and we're seeing both of those markets grow. So diving in here to how energy storage is being used, and I'm mainly going to focus on the commercial side today. I'm not going to be talking a lot about how utilities or IPPs can leverage energy storage. But when most people on the commercial side think about energy storage, they're using it primarily for peak demand shaving. And Seth talked a little bit about how peak demand and how those costs are going up. And I think it is the fastest growing portion of the bill for most customers. And we expect that trend to continue. So energy storage is a great way to shift load from when you're not using it, typically in the evening, to on-peak timeframes when you do have those higher demand charges. We're also seeing a lot of this combined with solar because of solar intermittency and resiliency and solar firming. We're now seeing about 60% of our projects tied to solar, which creates some financial incentives in many markets and opens up markets that have demand charges usually about $15 or higher. We're also seeing a lot of arbitrage, which I think most people think about. You charge when the energy is cheap and you dispatch when the energy is expensive. But a couple of other areas that are growing and we're seeing making more of a meaningful impact into the savings, one of which is demand response, where as you look at a fleet of projects within a utility or an ISO, you're able to aggregate that unutilized capacity and start submitting that into demand response programs. So today in California, we've got hundreds of systems that are tied together, and when the utility or the ISO needs either to have us charge or discharge, we're able to do that, and our customers are paid both a capacity fee as well as a utilization fee for that. So it's a great way to add additional revenue to the project. Some of the other areas we're seeing growing is backup power and microgrids. In many markets today, microgrids are not financially attractive as a standalone, but if you have backup power or resiliency needs, we're seeing those as a bigger component of our mix. A couple of other areas, especially on the East Coast in New England, we have capacity tag reduction, where, again, very similar to DR, we're able to dispatch energy when you have a peak capacity tag day, and that's been a sizable savings for folks on the East Coast. There's frequency regulation, which is another option that we can add. And usually you can combine, 3, 4, even up to 5 of these revenue streams within a single system. And the last one we see a lot is switching tariffs. So if you can, depending upon the utility and the tariff you're on, if you can lower the maximum level of demand, usually a couple of times a month or a year, you're able to switch them to a lower tariff, which has a lower cost and many times a lower fixed component and possibly even a lower energy component. So these are some of the ways in which energy storage is mostly being used to either create revenue or drive savings off the utility bill. I'm going to keep moving along here. And I think Seth covered a lot of this, but just to quickly go over, there's really the 3 components that he mentioned about their bill: the energy charges, which is really the kilowatt hours, the demand charges, and the fixed charges. Energy storage can really impact 2 of the 3, unless you're switching tariffs, which we can then impact the fixed charge. And for those of you who are not sure about peak demand, I'll show you exactly what our system does pretty much every day on a site. This happens to be a load profile on a 15-minute window of one of our customers. And so we install an energy storage system that is connected up to the main building meter. So the intelligent system will understand and see exactly what's happening with the building load at any given second. And what it does is at the beginning of each billing period, it automatically predicts and learns to adjust what is the maximum demand level that the utility wants to see. So in this particular case, you can see the middle of the day, there's a big spike that is costing this customer, thousands of dollars. And at the beginning of the day, you'll see as they start consuming it, we're using some of the energy in the batteries to flatten out that load. So what the utility sees is no longer the orange level, but is now this new green line. And there are times during the day that we can recharge in order to get more uses out of the battery. And as you see, we go throughout the day and we shave those peaks, and these can be done at different on-peak or partial peak or off-peak levels. By flattening out that load profile, you're able to get pretty substantial savings per month. So at the end of the day, then we'd go back and recharge and get ready for the next day. If we happen to have a demand response event, maybe in the afternoon or the evening, we could have incorporated that into this as well. But that's really a quick, basic understanding of how energy storage is being utilized to reduce peak demand charges. So now if we look at how it's combined with other revenue streams, this happens to be a school district here in California where you can see this happens to be a load profile of a high school, and we're actually combining multiple revenue streams here. And I think sometimes it's helpful to see where that revenue or savings is coming from. So the orange is the load profile without storage. The green is the new load profile with storage. And the gray bar is the stated charge of the batteries. And so what's happening here in the morning, the first thing the system does not want the demand to go above 400 kilowatts. Because if we keep it below 500 kilowatts, we're able to switch them from a GS3 to a GS2 tariff, which creates about $145,000 in savings per year. Just by peak demand shaving, this system is able to generate about $208,000 in savings. But what's interesting about this is if you look later in the afternoon, many schools get out in the late afternoon and are great candidates for demand response programs. So at about 3 o'clock, we're starting to dispatch our batteries because that is still the on-peak energy period. And we have enrolled them in a demand response program within their utility. And so we're dispatching energy when that demand response event gets called. So not only are they saving money by dispatching when energy is expensive, but they're also getting paid as their demand response. And the arbitrage in the energy adds about $81,000 in savings, and the demand response added about $42,000. And then you can see in the evening, we recharge our batteries in the night and get ready to do it all over again in the morning. Now, the key on this is traditionally most folks have only looked at the demand savings from peak demand shaving, whereas if you combine these multiple revenue streams, you're able to get over 2.5 times more savings with the exact same asset. And that's really where I think the sophistication of the market is going and being able to figure that out. And I can tell you from experience, it is a lot harder to do in real time than it is on PowerPoint and a spreadsheet. So I know there's a lot of folks still trying to figure it out, but it does take a while, I think, to get your algorithms and the predictive nature of each customer and load profile to really dial those in and make them effective. So who's using energy storage? You have everyone from a 7-Eleven, which has got about a 30 kilowatt load, to maybe someone like a Kaiser Permanente, which is a large hospital that's got anywhere between 3 and 8 megawatts of load. Sierra Nevada Brewery, they've got high volatility in how they make beer. You've got folks like UPS or the public sector, whether it's schools or colleges or water treatment facilities or supermarkets or Kohl's. So it's really a broad spectrum of people that are adopting and installing energy storage, but the net result is all the same, is how do you create savings or offer resiliency for them using a common platform and software solution. We also have a lot of utilities that use this, both behind the meter deployed on customer sites, as well as in front of the meter to help them stabilize their grid. So what are the key components of an energy storage solution? I think there's really 3 things that most people think about when they are looking at energy storage. The first is, what is the software and how does that help combine with multiple revenue to drive the most amount of savings and benefit for the client? It's also a very interactive screen where any client can come in and really look at what is happening with their software in real time. And many people start to learn more about their building and things that are happening that are creating cost from their electric bill. And so it's a great visual way to really understand exactly what's happening with your facility and learn from it. The second key piece is really, what is the battery storage system? And so that usually combines an inverter, batteries, an enclosure, an HVAC unit. And we're seeing more and more of a trend where these are being installed outdoors. For those of you in California, there is a new regulation coming in next month, which is making it very difficult to install these units indoors. New York has also made that very difficult to get them installed indoors. So we're seeing the bulk of the energy storage systems installed being an outdoor system, usually installed close to the utility meter, and they come in various different sizes, which I'll talk about. The third item is really around, how do you pay for it? And we're seeing a growing trend more towards cash purchases, but there are also a number of financing options available to customers depending upon what they're interested in. Coming over here to really looking at what a software platform looks like here. So this happens to be a screenshot of one of our clients, and what you're seeing here is this system happens to be installed with solar. So you're seeing the load profile in the upper left, which shows what the total building consumption and solar generation looks like. So the green is what the load profile is after solar and storage is installed. The red is where you're seeing the solar is offsetting some of the load, and you'll see, if you can look closely, some of the orange, which is where the battery system is really deploying to reduce peak demand charges or arbitrage. If you could look closer on this, you can see there's blocks in the afternoon where it's like a chunk in the green, and that's where there's a demand response program that the batteries are being utilized for. This also can show you solar production, how the two of them work together. I think one of the unique things we've learned over time is the variability of solar can dramatically change the savings from an energy storage project. So by being able to take that solar production data and really create a local expectation of what's being produced from the solar system can create significant increases in savings with the storage unit. So really integrating the two systems we've seen as being a key. We're also starting to see more DC coupled systems where the solar system and the energy storage system are combining the same inverter. The other thing about this portal is you could look at each individual site, a portfolio of projects. They can all roll up, consumption, savings, financial impact, your utility tariff. So it's a really nice window that people can look at and really see what's happening. We have many clients that are integrating that into their energy management system so they can tie the two together. And I do think that we're seeing more and more virtual batteries of being able to combine standalone batteries with shedding load within the building to get further savings without adding additional batteries. The next key component, as I mentioned, is the hardware. And hardware tends to kind of get classified in different areas. On the commercial side, usually the smaller portion is about a 30 kilowatt inverter and a 60 kilowatt hour battery configuration. Most systems are, there's a couple different duration of batteries you can use. I think the most common, especially in California, is a 2-hour system, which means if you have 100 kilowatts of inverter capacity, which is the maximum you can put out, you usually have about 200 kilowatt hours of batteries. And that's mainly because it optimizes the S-chip incentive. But when you combine with solar, that may go 3 hours or 4 hours of batteries in order to get longer duration or building loads that tend to be flatter. But on the commercial side, the most common building blocks that we see are a 30 kilowatt, 40 kilowatt hour, or I should say a 30 kilowatt, 40 kilowatt inverter up to about a 1 megawatt, maybe sometimes even a 2 megawatt inverter, and then the batteries being slightly bigger. And those tend to be modular systems that can be used as building blocks. Once you get into the industrial, we're seeing more and more containers, where these containers typically go in to be a 2 megawatt to 20 megawatt hour systems that really are for larger customers with loads above 3 megawatts. And then on the utility side, or in some cases, huge data centers, we actually custom build centers where we put in steel enclosures, indoor racking for the batteries and outdoor inverters. And once you get to about 10 megawatts, 20 megawatt hour systems, that tends to be more economical. There is a broad set of different inverter manufacturers and battery providers. Some of the ones that we see out there in the market are obviously Samsung, BYD, Tesla, LG Chem, and each of them are a little bit different depending on the chemistry, their costs, their warranties, their repair times. So it's important to really read the details of each of those and understand are they best suited for your application, because someone using frequency as the primary revenue has a very different configuration that someone's using a 4-hour battery for long dispatch. And so you have to really understand the difference between the uses and which system is optimized and it is really going to fit your needs. I think one of the other key things that we see a lot on batteries is sizing. Financially, on paper, it looks great to put, let's say, a 100 kilowatt system on a 2 megawatt load, and you're getting almost 100% utilization and reducing demand charges. The problem with that is it's very rare you can predict the exact kilowatt maximum per month per period. And so your risk is significantly higher, where if you miss 5% of a 2 megawatt load with a 100 kilowatt system, you've wiped out all your savings for the month. So sizing is another critical piece in order to reduce your risk and size it appropriately. Moving here to what are the key things that you want to look at in sizing a system. It is really around the load shape of the customer and their load profile, which can vary greatly. The volatility and the consistency of the load. So the more volatile the system, you may want, like I mentioned, larger systems to reduce that volatility and minimize that downside risk. If they want backup power, we're seeing more and more requirements where you keep a certain percentage of the capacity of the batteries for backup power. And so you'd want to size that into your economics. Is solar installed? We typically see the battery ratio between solar and storage. If you have a megawatt of solar, you're typically looking at about a 500 kilowatt, 1 megawatt hour battery system to pair up to that. And then obviously financial returns, right? Because if you can use a smaller system at a comparable risk, you're going to get better savings on the financial. So many people ask, well, is storage ready? Is it financially attractive? We typically see, for example, in the San Diego market in California, with the SCHIP incentive there, on a cash basis, our typical returns are between 2 and 4 years on a customer that has some volatility. If you go to New England, you're typically looking if you're combining it with solar as part of the SMART program, those tend to be about a 3.5 to 6 year payback. If you're looking throughout California, they tend to be in the 3 to 6 year payback, depending upon the load profile. And so just to give you some ideas of what we're seeing from a payback perspective. I talked a little bit about the risk of undersizing. One of the other things that we are seeing more is if you are going to be changing the load of your building. So if you're adding capacity or reducing capacity or doing energy efficiency projects, you want to make sure you understand what that impact could be for your savings or for the battery sizing. Coming to some examples, because I think it's always helpful to see exactly how battery performs differently, is this happens to be a manufacturing site in PG&E in Northern California. And you can see it's a very flat profile. So they happen to run a dual shift and sometimes a 3 shift. And the orange line is what the load profile was without energy storage. The green is the new profile with energy storage. And the gray is the state of charge of the batteries. So you can see in this, the software is really designed to be charging at night. And then once you get into the on-peak period between 12 and 6, they're going to be dispatching energy for 4 to 5 hours. That C is the peak demand for that month. In this particular case, this 1 megawatt, 2 megawatt hour system is saving the customer almost $200,000 a year from just the energy storage system. If I go to a different profile, which in this particular case happens to be a Southern California high school, you can see the load profile is dramatically different. And in this particular case, we have a 750 1.5 megawatt hour battery that is really fundamentally changing the entire shape of their load profile. And you can see how that orange used to be spiky in the morning, and now we've made it very blocky, and it's optimized for the time of use rates. One of the nice things about energy storage is SCE has filed a petition to change their on-peak time from what is now noon to 6 to later in the afternoon. So if that moves to 4 to 9 p.m., we will automatically, the software will adjust and recalibrate to get the highest savings for that particular site. So in a lot of ways, it gives you some comfort in investing in that technology and being able to use that later. In this particular case, this high school, it saved them about $100,000 per year. If I give you another profile here, this happens to be a brewery in Northern California, and you can see some of the real volatility in their brewing process. It's the same approach here. We're really flattening out and using those batteries for a longer duration here and creating about $104,000 a year in savings. All of those are very different profiles and require different algorithms that are able to adjust to that in order to get the maximum savings. Moving here to some of the paybacks that I mentioned and some of the ways in which you can procure it. I think for most of the clients that we see in a cash basis, you're seeing about 3 to 6 years is kind of the average when you have an incentive program. There are a number of different financing solutions. The ones that we've seen in the market that are, I think, attractive, one is a shared savings agreement. Some people may have heard of that as a power efficiency agreement. That's where the owner and operator of the system installs a energy storage system at the customer location at no cost, and then they share the savings. And those splits, depending on the savings amount, can vary anywhere from 20% to 50% to the customer. We're also seeing more of a fixed payment model where It's similar to a lease, but slightly different, where the customer has a fixed payment, and then they're able to get all the upside beyond that fixed payment in savings. So it's the same approach where the owner or operator of the system installs it, and there's no capital outlay for the client. They have a fixed payment each month, and any of the saving that's generated above that is the benefit to the customer. The nice thing about that, and the pros and cons, is the capital requirements and risk on a shared savings are higher, and so there tends to be a lower benefit to the client. Where in the fixed payment, because it's a fixed revenue stream and the investor is not taking that risk, they tend to be able to offer a more compelling and beneficial savings to clients who take that approach. We've also seen a lot of public financing, whether it's through Prop 39 funding or bonds or local programs that allow public entities to use that because they tend to be at lower capital rates. We also see a lot of solar and storage sold together through a PPA, and there's two approaches there. One is a PPA where you would continue to pay, let's say, 9 cents per kilowatt hour for the electricity that's generated, and then you would pay a lower demand charge for the amount that the energy storage is able to offset. So if you're paying $20 in demand charges by installing energy storage, you may only pay $15 per kilowatt for all of the demand that the energy storage system is able to reduce. The other way, which we're seeing grow and get more traction on a PPA, is an increased PPA, where if you would have traditionally just paid 9 cents per kilowatt hour for the solar, you may pay 10 cents per kilowatt hour for solar and storage, but you're getting 100% of the benefit of the storage. And that tends to be a more financially attractive solution that we've seen in the market. And we're seeing a lot of ESCOs that are installing energy storage in both the federal as well as the public sector with performance contracting, where they're wrapping that into energy efficiency, solar, other programs, and guaranteeing a fixed amount of savings for the entire project. So all of those are some options we're seeing. There's a few others that are smaller, but there's lots of ways to get energy storage into your facility, and hopefully there's a financing or a cash purchase process that works for you. So what do some of these systems look like? You've got a couple different configurations here. On that left here on the bottom, you've got a couple 4 30 kilowatt, 60 kilowatt hour systems. On that upper left is a 250, 500 configuration, and they're modular. So these tend to go in very quickly. They're pretty easy to install. You're typically on site on a 250, 500 for a couple weeks. You pour the pad, you drop the unit in, you wire it up. You're in and out pretty quickly. So it's a very not very evasive when you're installing these. A lot of people want to know, well, how much real estate does it take? So kind of a good rule of thumb that I've seen is for a 250, 500 kilowatt hour system, you're slightly more than half a parking spot. So most people are able to find that type of sizing within their facility. Here's a couple of other pictures that you can see deployed. This one here happens to be in Poway Unified School District in San Diego. They've rolled out 9 different sites within their district. It just happens to be one of them, and that's a 501 megawatt hour system. You'll happen to see Safeway. These are a couple modular systems that they have installed behind some of their facilities. This is a early version of a product, and this was MDLA, which is a high school district out here in California. Interestingly enough, they had very little space to put these in. So they had to be smaller systems installed in very close proximity with flexibility in where to put it. So you've got almost 30 systems that are installed on their 2 campuses divided up, but all acting as one system. This happens to be a system up at Sierra Nevada Brewery, which is interesting because it's combined with cogen as well as solar. And it's a really interesting application where they're trying to minimize the amount of power that they're taking from the grid. And lastly here, this happens to be a community college district in San Diego, where we have smaller units deployed on different campuses, as well as larger 250-500 systems. And lastly here, this happens to be a industrial client. You can see with a group of 250-500s. This happens to be a 750 1.5 megawatt hour system deployed at a biotech company. And hopefully you're getting an idea of some different ways in which these systems can be used. And so really, I think what I want to do now is, given that we've got, over 300 people on the phone, I'm sure we've got a lot of questions, and I'd like to hand it back to you, Seth, and maybe we can really direct the conversation to where the audience is interested.
Excellent. Thank you, Steve. That was a great presentation. It covered a lot of really valuable areas that I was hoping that you'd get to. So excellent. We do have a lot of questions, so I'm going to apologize to folks ahead of time. We have a good amount of time. Thank you, Steve, for wrapping that up for question time. We still may not get to them all. I think we do have ability to stay a little longer. So we'll get to what we can. To start off with a couple of areas that generated multiple questions. One was the siting of energy storage. And I was aware that there was some difficulty in New York City due to concerns by the New York City Fire Department about just some hesitation and concerns, making sure they figure out all the safety aspects of energy storage indoors. I had not heard on the California side. So maybe you can talk a little bit more about that in general, the move to limit indoor siting of energy storage, and just what's driving that overall, if it's different in California and in New York City, or if it's pretty much the same.
Yeah, I think you'll see as jurisdictions and code catches up with technology, they are trying to figure out how to make this as safe as possible. And we have not had an incident or any concern with any issues with our energy storage system so far to date, but I think they're really trying to be protective around what are some of the critical things you'll need within indoor installations. And we've done a lot of indoor and outdoor installations. But what you're looking at now is the adoption of 2-hour firewalls within facilities, a maximum amount of electrolyte that you can install within an indoor structure. You're looking at fire suppression that needs to be built in. You're looking at a number of different things that they're adding into the code, which makes the cost to install them almost be 2 to 3x. And typically when you add 2 to 3x to the installation cost, which currently right now is about on a 250-500, about 20% of the total project cost, it does hurt the economics significantly in many of those situations. You've also got, when you have them installed indoors, we won't install a system without an HVAC unit anymore. Some of the problems that people have had in the industry is where they've installed units indoor without HVAC, and the units have overheat and the inverters have caught on fire. We'd prefer to put that investment up front and build in a control system within the unit, so you're not relying on an outside entity to cool the system. So that's one area on just venting from indoor and thermal transfer of heat that you've got to pay attention to. So this code requirement that is going to affect at the end of the month is really around those new provisions in California. And we have been working with fire departments in a number of different states that are looking to adopt similar codes for indoor installations. We have not seen anything from an outdoor perspective that has caused us concern. So I think that trend will most likely continue really for indoor and adding some cost on the installation side. So I don't know if there was more specific questions or things that I can help with, but glad to go into more detail, or also if folks have specific questions at the end, I think there's an email address that you can send and we can answer your questions specifically.
Yes, that's great. That's not up right now, but I think it was info@ngstorage.com. And if you don't have that, feel free to reach out to me too, and I can get your questions over to Steve. That's seth@cleanegroup.org. And for folks that came in late, just to let you know, the webinar is being recorded and the slides will be available. That should a link to that should go out later today or tomorrow. Another interesting question that a few folks raised was electric vehicle charging, and a couple of different aspects on that. One is, more and more commercial businesses are starting to install EV chargers on site, and just how that impacts the payback of energy storage and how that plays into the economics there. The other question, if you can address this, is high-powered EV charging, the quick charger that are high-power applications. Does energy storage play into deployment of fast chargers for EVs? And are there electric tariffs that play into that? Are there specific tariffs for EV chargers, and do they face high demand charges as well? So it's pretty broad areas. Answer what you can there.
No, it is, and it's a great question. As you mentioned it, I thought, wow, I really forgot to add that to my presentation, because EV charging is probably one of our fastest growing segments for battery storage. And the high-powered DC fast chargers are a key area that we see combined with energy storage quite a bit. And I'll give you an example. If you have a single 50 amp DC fast charger, which is a high voltage, not as high as some of the higher ones, but a good medium-sized fast charger in San Diego, that adds about $2,000 a month in demand charges to a client that installs it. So rarely can you ever recoup that cost. And so what we've been doing is installing batteries with EV charging in order to minimize those spikes that happen with the DC fast chargers. You're seeing a number of rollouts across the country with ChargePoint, EVgo, Electrify America, Tesla, that are all adding energy storage as part of that rollout because of the high cost of demand and the ability to use energy differently and more cost effectively. We are seeing more and more commercial clients in cities and governments and fleets that are being added to different transportation providers, short haul, long haul trucks, et cetera, buses that are electrifying their fleets. And demand is a critical question that they come up with. And so we're starting to see many of those folks package it together. So it's an excellent combination. EV charging is our best performing segment from a what we expected versus actual. So I think it's a great market, and I would definitely encourage anyone who's thinking of installing EV charging to look at energy storage, because they're very complementary.
Great, thank you. Now, so a couple of questions that are somewhat related here. One, just in general on the payback periods you mentioned, the 3 to 6 years. Are those with incentives only, or are you seeing those outside of incentive opportunities as well? And kind of related to that, you mentioned California, where they have the S-chip incentive, self-generation incentive program. And then New England, which Massachusetts now has, they're implementing their SMART program, which has incentive. Do you see other areas where energy storage, the economics are looking good? A couple of people specifically asked about the PJM territory, which is mid-Atlantic states. So thoughts on those?
Yeah, no, it's a good question. Obviously, the most attractive markets in the U.S. today are California, Massachusetts with solar. New York can be somewhat attractive. There's parts of Hawaii. There's some niche markets where the demand charges, as you had shown earlier in your slides, are above $20. And when you combine it with solar, those can be attractive. The challenge with PJM right now is the frequency market there, and the value of a fast response frequency has dropped considerably. And there are a number of large projects coming online there that have created that, really reduced the value of that market. So I see it as a complementary market where you can do frequency in addition to peak demand shaving and combine with solar. There's some New Jersey solar benefits there and incentives as well. So we see that as a hybrid market, but not one of the top four that we see. Ontario is a very interesting market with their global adjustment charge. And there are some markets that we're starting to see in New England that when you combine multiple revenue streams, they're very close to being attractive without an incentive. And that's really where the market needs to go. So as we see more declining costs, hopefully on equipment installation, and better leveraging some of the utility programs that can add more revenue, we'd really like to see a market that doesn't need incentives.
Yeah. So you mentioned pairing solar and storage together. We had a question on the investment tax credit. Energy storage is eligible for investment tax credit when paired with solar, as long as at least 75% of the charging is directly from the on-site solar. There was a question just about the management of the storage systems. Can your systems or the software that runs your systems or manages your systems keep that into account and make sure that the charging is appropriate to be able to take advantage of the IRS tax incentive?
Yeah, it's a great question. And yes, you absolutely need to have a software platform that can manage the incentives and help report back, because one of the things you don't want to do is obviously hit that cliff on the ITC, because then you get zero from the ITC. So what our system would automatically do is you program in, and it can be somewhere between 0 and 30% down, where you set the ideal amount based on your financials that you want the energy storage to charge from the solar system. Most of the time, our guidance is somewhere between 75 and 85%. And you can go higher, but it may impact the demand charge savings and when you recharge. So it depends on the site. But our system tracks that, monitors it, and reports it. We have an ITC module that does exactly what you're describing in order to protect the investor or the customer and make sure they're getting all the incentives that they thought they were going to be getting.
Excellent, great. So this is an interesting question, and I'm not sure if it's an area that Engie gets into, but it was specifically asking about the supermarkets and things that have refrigeration-intensive load profiles. I know that there are companies that look more at the thermal energy storage side to attack those. Is that a market you get into at all, or anything that you have experience with?
Yeah, we some of our clients are Safeway, Whole Foods, Albertsons. We've got a lot of regional markets, and so we've definitely played in the supermarket space. And excuse me. One of the things I've noticed is many of the large chains have been very effective at reducing their peak demand and using software controls, refrigeration controls to really flatten out their load. We've seen some of our systems now that have been running for about 5 years in that space, and it's been really interesting to see how they've used technology to flatten out their load profiles. Where we're seeing a growing trend is in backup power in the refrigeration. So in the event that you've got a down outage, you can still keep your freezers and refrigerators cool in order to preserve the food. The second piece is really participating in demand response and other programs, because they really can't shed load effectively, because it's mainly lighting, HVAC, cooling, refrigeration, and they don't want to impact the customer experience. So by leveraging energy storage, you're able to get that additional benefit there. I do know that there are some folks that have just developed solutions around refrigeration for supermarkets. We've really focused on the larger entire cost structure of the building, but I would say it's not a bad market, but it's probably not the most attractive market given their focus on flattening their load.
Mm-hmm. Okay, great, interesting. So a question, and I can address this a bit. It's just someone that is working on projects that are related to resilience, and specifically outages from major disasters, so probably more long-term outages. And just what are the different design considerations for that type of project compared to one that's managing demand? I know from experience that we've had through the Resilient Power Project, generally, I think we've found, and Steve, tell me if you would agree, is that demand charge management tends to be a relatively modestly sized battery for the overall load, whereas resiliency, depending on what you're trying to back up, and particularly if you're looking at extended outages, it tends to be a much larger battery that you need to meet those needs. Has that been your experience, or do you have any additional comments on that?
Yeah, it is. I think it really comes down to what does the customer really want to achieve, right? And I think people definitely get into a dilemma of, oh, I'd love to have my entire facility running forever. But when you look at the economics of that, it rarely ever pencils out. What we see more common is a subset of the building that needs to have backup power, or a subset of the load. So, for example, you met in shopping and retail, they're only looking at refrigeration and lighting, or in retail, or non-supermarket retail, you're looking at just really lighting and cash registers. Or we have a lot in our industrial and manufacturing sector that really needs an hour to 2 hours to be able to properly shut down their equipment and not have, if you're an injection molding company and you lose power and now all your material is stuck in your machine, it can cost you $1 million+ to get that out and reconfigure and take out the damaged parts. So we also see it in schools where they're really looking for a couple of hours or just to run phones and central command, or shelters that are kind of the emergency response centers within a gym. So all of these are great applications that don't require running the entire facility, but are financially attractive. And what we do in our software is we really identify, well, what are the needs of the client? If they just need an hour, then how do you reserve an hour of capacity at all times in order for them to achieve what they're looking for? Another thing that we're doing, which I think is pretty interesting, is we've developed a kind of a storm watch application where you may have less of a critical infrastructure and you can change the amount of capacity that you store for outages depending upon when or how storms come in, if they're the main driver for outages. So that way, maybe at 9 months out of the year, you're getting 100% benefit of the batteries, but when you have an ice storm or you have something that traditionally would take the power out, we're putting more reserve capacity for the backup power. We're saving a little bit less money, but there's a higher chance that power will go out, and so how we're using the capacity of the batteries is different.
Great, yeah, and I'll just add to that. We've seen some folks that we've worked with that have tried to design, let's find the most economic system, and then because resiliency is a big component to their goals, they'll say, okay, well, what's the largest energy storage system we can get that economically we get, say, a 10-year payback instead of 3 or 4 years. So we can not have the net present value may be around 0 for the battery, but we get that added resiliency. And so how big a battery can you get without having to put a lot in, and how much resiliency can we get out of that?
Yeah, I would agree, and I think most people are finding a way to value what is the resiliency component, and they add that into their economics.
Yeah, that's an excellent point. So you talked about a number of different value streams, and a couple of questions related to that. Some was just, maybe you can explain a little bit more the difference between demand management, demand response, and capacity tag reduction. What are the difference between those value streams? And when you're designing a project for multiple value streams, how do you go about prioritizing or getting the right size battery to meet those different needs?
Yeah, it's a great question. And a lot of this is, we have a tool called Prospector, which is our simulation engine, which optimizes size and performance based on those revenue streams. So we used to have a team of, a dozen plus analysts that would have to figure this all out manually. And now we've automated that, where our internal team or our partners can run a lot of that analysis in an automated fashion that optimizes those revenue streams. But to give you a backbone of that is the first thing it does is the software identifies what is the most critical or highest value revenue stream for that particular site. So if you took in the description you had, most likely it would be I'm assuming that's from a New England or an East Coast client who asked the question, is you have a capacity payment from the ISO, and it typically is 4 or 5 days out of the year where whatever your highest demand is sets your cap tag for that year. So what you would do is, obviously that would be the primary, it would take primary over any other revenue stream when a potential 4 CP or 5 CP day was being triggered. And the system would know that beforehand. So it would automatically readjust the algorithm to assume a 2 or 3 or 4 hour window for that, and it would try and maximize the savings for that. On non-4 CP days, it would take the next most valuable revenue stream, which is most likely peak demand shaving, and it would optimize the system for that And if it wasn't being utilized based on the expected profile, it could do other revenue streams like arbitrage or demand response. So the nice thing about it is this is an automated approach where the system, based on the value of the revenue stream, will manage it for you. Now, we do give control for clients who would want to have manual dispatch where they can override our controls. They may have some reason to do that, and we do allow that functionality if they're interested. So I don't know if I've covered all of those, but I think there was a question is what are the differences? I think demand charges are obviously demand management. Capacity tag reduction is something from a utility or from an ISO. And then DR is just an additional demand response revenue program with the utility as well. And sometimes load profiles won't make sense, right? So there are demand response programs in New York, which it could be an 8-hour or 6-hour window. Well, that may not be a great demand response program for energy storage.
Yeah, so I see we're at the end of our scheduled time. I think, Steve, you said you have a little flexibility, so we're going to try to do, say, 5 more minutes with questions, and then I'm going to turn it back to Sam to tell you about some upcoming webinars. But we'll try to get to a couple more questions here. I had a question on financing, and this has come up with some other things, solar related. Is PACE finance an option for energy storage? Is that something that you've gotten into in the projects you worked with?
It is, and definitely an option.
Okay, great. Actually, a question related to the multiple value streams. Just that in practice, this attendee says that they've found value stacking to be a tough prospect, whereas it sounds nice, that it's difficult in practice. Is that something that NG does on a regular basis, or is it tend to be really focused on one value stream and the stacking is just not really the major opportunity?
I think it depends on the market. For example, I would say probably 80% of our projects in California are stacking multiple revenue streams by design. And whoever asked the question, I think is a great one, because there's a lot of folks that are trying to get into energy storage, and revenue stacking looks great in PowerPoint and on spreadsheets, and it's a lot harder to do in person when you're doing it every day on a load that changes that you don't know. And I think that's a key thing, and it's an area that your performance of really what your actual versus expected is a critical metric that customers really need to pay attention to, because there's still a number of folks out there that are like, oh yeah, here's perfect savings, which is a theoretical perfect maximum that you could achieve if everything was perfect. That never happens. And if that's your financial baseline, you're going to be disappointed. So I would really look at the D rates of expected savings and do a litmus test. If you really think they're going to guess the peak demand 95% of the time, every single month perfectly, I've never seen it, right? So we tend to see D rates more in the 15 to 20% range on a volatile low profile. And if you're adding solar, I know we derate our savings 30% because of the volatility of cloud cover and unpredictability. So I think the industry does have to come up with conservative metrics that people can count on and offer guarantees that are going to, basically force you to have savings that you can hit on a regular basis.
Yeah, great. So I think we have time for one more. I think this is a really interesting question. Talking about power purchase agreements for solar and battery storage, or just for battery storage, where the system is designed to provide resiliency in addition to savings. Our clients are, well, for one, are PPAs structured for resiliency projects? And if so, are clients willing to pay a premium for that resiliency benefit? Is that incorporated into the PPA? And again, I guess if so on that, can it still come in under the utility rates, or is that kind of a premium up and above utility rates for that reliability and resiliency value?
I think it depends on the market, but we're absolutely seeing that as an adder into the PPA rate for resiliency. It would not be a whole building in most cases, it would be a subset, but investors are comfortable with that because they're still getting the PPA rate from the production of the solar system. If the power goes out today, they make no money. So it isn't impacting the revenue stream from a financier. And so by adding resiliency in, you're adding a cost component. So maybe it adds 2 cents to the PPA rate, but now the customer can get backup power and not impact the revenue stream of the financier, and everybody's happy. So it's really just the financial incremental amount. And where the cost gets higher is you've got to create a critical load panel and switch gear within the building to manage a smaller load. And you just need to be careful that that cost doesn't get too high where it makes it, non-financially viable. But definitely a trend, definitely something we're seeing, and I think an area that will continue to grow.
That's a great point too, that, just having solar, well, solar alone for sure, you don't get the resiliency value. Solar and storage, you still need those extra components to make sure that the system is islandable and your critical loads are isolated. So any project needs to factor in those costs. Okay, so I think we're going to end there. There were a lot of questions we didn't get to. Please do reach out to myself or to Steve with any questions that we did not get to. Steve, thank you very much. This has been a really informative webinar, and I think we're going to have a lot of people viewing this later on. We're certainly going to spread the word to our networks about this. So very much appreciate you joining us for this and sharing your knowledge. And with that, I'm going to turn it over to Sam to let folks know about a few other webinars that we have coming up.
Thanks, Seth, and thank you, Steve, as well. So we do have a bunch of webinars coming up throughout the summer related to energy storage and resilient power, and also on some other pretty interesting clean energy topics. So on your screen, you will see some info about just a sample of those webinars that we have coming up. There are many more on other related topics, so I encourage you to sign up for these. You can do that by visiting our website at cleanygroup.org/webinars, and we'll be sending you a follow-up email sometime this afternoon with a link to the webinar recording and slides from today's webinar. And in that email, I'll also include some registration links for these webinars, particularly the one on June 27th, which is brand new. The topic for that one is Resilient Power in Practice, Lessons from the Field. So that should be very interesting. We are excited about that one. And again, I'll include a link to that in our follow-up email today. So if you're looking for more resources related to resilient power, as Seth mentioned at the beginning, our website, resilient-power.org, is a great place to find those. You can also connect with us on Facebook and on Twitter to get more frequent updates from us. And if you've got other questions, feel free to contact Seth. I'm sorry, that is not the right email. It's actually seth@cleanygroup.org. Sorry about that. But do get in touch, do find us online, and check out our other resources, and we hope to see you at the next webinar. Thanks, everybody. Bye.